For this video lesson, I want to review these terms, and then in the second part of the video lesson, we will review different types of graphs. These vocabulary words should be in your notebook. You want to take a moment and find the page in your notebook where they are so that will help you in the next few questions. The first question I have for you is to find the mean of this data set. You want to remember that in our case, we're looking at the arithmetic mean, which is the same thing as the average. To find an average, you want to add the numbers up and divide by how many numbers there are. So find the mean of this data set. The mean in this case is 14.4. Mode is another word we learned. The mode is the most common value in a data set. What is the mode of this data set? Sometimes we can have more than one mode, and sometimes there's no mode at all. But in this case, we have a mode. The most common number is 30. The median is the middle number, but you have to be careful to put the numbers in order before you try to identify the median. So after we put these in order, we can see that our middle value on our list is 7. The range is the spread of the data. How big is the spread between the largest and the smallest numbers in the data set? So in this case, our spread is from 30 all the way down to 2, so our range is 28. Now we also have looked at a lot of different visual representations. Bar graphs, frequency graphs, and histograms really look a lot alike. Box and whisker plots we reviewed. We're going to look at scatter plots and stem and leaf plots later. So this is a frequency graph. It looks like a bar graph. Every bar tells you how frequently or how many points in the data set belong in that group. So the data gets grouped in a frequency graph. This graph can tell us the mode. The mode is the most common value. So 30 to 39 is the most common score on this science test. We can also get a rough idea of the maximum and the minimum, but not a precise idea. And we can also see that the data is sort of skewed going down this way to the left. And we'll talk more about data skew later in this presentation. One other thing we can figure out from this frequency graph is exactly how many students took the test. I can simply add up the height of every single bar. This bar is 11 students, this bar is 6 students, this bar is 7 students, this bar is 4 students, and this bar is 2 students. So if you just add those up, 2 plus 4 plus 7 plus 11 plus 6, you would know how many students took the test. How many pumpkins have a mass greater than 6 kilograms? So in this case, you want to look at the axes and read them. It's a frequency graph. Each bar is telling us how many pumpkins had a mass in that range, in this case between 3 and 6 kilograms, and for this bar, 6 to 9 kilograms. So we can see that the most common mass was between 6 and 9 kilograms, because this is the tallest bar, so that would be my mode. But if I want to know how many pumpkins have a mass greater than 6 kilograms, I have to add up all of the bars that have a mass greater than 6 kilograms. I have to see how many pumpkins there were in this bar, plus this bar, plus this bar. So I'd have to add up 2 plus 6 plus 8 to answer this question. Similarly, if I want to know how many games were played total in this tournament, I would just add up how many games were played or how tall is each bar. So that requires you to read over here and see that this bar would be 1 high, and this bar, which is between 4 and 6, would be 5 high. And the tallest bar would be 8 high. So there's 8, here's 5, and here's 1. So you'd add all those up to answer this question. This is a different sort of graph, a dot plot. But just like the last one, we can figure out how many were in the survey simply by counting how many dots there were. 1, 2, 3, 4, 5. So there were 5 different sets of data that were collected. The range of time brushing teeth is from 2.5 minutes to zero point 0.5 minutes. So there's a 2-minute range in the amount of time spent brushing teeth. And the mode, or most common response, is 1 minute. We could find the mean of data simply by finding the value of each data point. This is 1 and 3 and 5 and 9 vitamins. So you can find all of those values and then find their average. So in this case, we would add up all of these data points. And in this case, we would divide by 5 because there are 5 data points to find the mean or average number of vitamins that this guy's mom took every day. Now, a box plot is used very frequently in science. In this box plot, we've learned that the minimum is on the far left, so there's my minimum, and the maximum is on the far right, so here's my maximum. It looks like it's at 69. And the median is this middle of the boxes at 54. So a box plot, or box and whisker plot, shows you very clearly the minimum, the maximum, and the median. It also shows you what's called quartile 1 and quartile 3. It divides up all of your data into 1, 2, 3, 4 parts. Each part is a quartile. The upper quartile, and this one is vertical instead of horizontal. So the upper, this is the top 25% of the data. The lower quartile is the bottom 25% of data. And everything inside of the box is the middle 50% of the data. And this area, the width of the box, is called our interquartile range. Sometimes there's a dot somewhere in your box plot, and that's where your mean or average would be. But you don't always need to have it exactly labeled. I'll show you how you can figure it out. So for this one, because there's a long tail to the right, that tells me that my average is larger than my median. There's the average. This data over here is dragging the average up. I don't know exactly where my average is, but I know it's more than the median, so it's more than 40. But what is the range of this data? Just like when we found range in other questions, we're going to take the maximum and we're going to subtract the minimum to find our range. The interquartile range is only the range in the box. So it's between quartile 3 and quartile 1. So quartile 3 again is this spot. The median is actually quartile 2, but we don't usually call it that. Quartile 1 is this line here. So my interquartile range is just going to be, in this example, from 50, the bottom of my box, to 59, the top of my box. So I will simply do 59 minus 50 to find that interquartile range. We like to find that because that tells us where half of our data is. And it's the data that's usually close to the median. Well, it's got to be close to the median, but it's also usually in that 50% of the data that we will also find the mode, and also we'll usually find the mean or the average in that interquartile range. For this box plot, if I want you to tell me what percentage of the data have values that are greater than 92, first you have to find 92. Here's 90, and here's 100. I've got 1, 2, 3, 4, 5 spaces. So each space must be 2, because this is a spread of 10. So 90, 92, 94, 96, 98, 100. So if this is where 92 is, and that's my quartile 3 mark, then only 25% of the data would be greater than 92. So a box plot shows you the range. You can see the maximum, the minimum. In this case, my maximum is 90 and my minimum is 0. You can see the median, which in this case is between 20 and 30. I'd guess it's about, I don't know, 23. You can see that 25% of the data was this low, and 25% of the data, the top scores were really spread out here between about 36 all the way up to 90. And because there's this long tail to the right, I know that there is a right skew to the data. So I know that my average or my mean is larger than this median, which looks like it's about 24, did we say? 23, 24? So once again, if there's a long tail to the right, then the mean or average is greater than the median. If the long tail was on the left, then the mean or average would be lower than the median. In a frequency graph, as we said, you don't see the exact maximum or the exact minimum. This is the exact same information that was on that last slide, right? This last slide showed me the exact minimum was 0 and the exact maximum was 90. This graph doesn't tell me if my two students that scored down here got a 0 or a 9. I'm not sure. Nor does it tell me exactly what my maximum was. But this does show me the mode. So you get different information from different kinds of graphs. This is the graph. My bad. This is the graph that goes with that last one. As you can see here, I don't know if my minimum is between 0 and 9, but here I can see that the lowest score we got was a 9. And I can see the highest score we got was 44. I hope you understand how I got 44, even though it's 2 boxes past 40. Versus in the last graph, I only knew that the highest score was somewhere between 40 and 49. This box plot has a left skew, a long tail to the left, so that tells me my average is less than my median, which is 34. It does tell me my median, but this graph doesn't really tell me my mode. This graph makes the mode obvious, that the mode is between 30 and 39. It's not so obvious here, except for the fact that this grouping of 25% of the data is much more squished together. So I might guess that my mode is somewhere in this location.